Brake system operation. The brake system is a critical component of a vehicle's safety system, ensuring that the vehicle can stop efficiently under various driving conditions. Understanding how brake systems work is essential for diagnosing, maintaining, and repairing these systems. This lesson will focus on the operation of hydraulic braking systems, which are widely used in modern vehicles, and provide a detailed explanation of ABS or anti-lock braking systems, and electronic brake systems, which are increasingly common in advanced vehicle safety systems. How hydraulic braking systems work. Hydraulic braking systems are used in most modern vehicles due to their reliability, efficiency, and effectiveness. The system uses hydraulic force to apply pressure to the brake components, which in turn slows or stops the vehicle. Basic principles of hydraulic brakes. Hydraulic brakes operate on the principle of Pascal's law, which states that pressure applied to an enclosed fluid is transmitted undiminished to all parts of the fluid. This allows a small force applied to the brake pedal to generate a much larger force at the wheels. Components of hydraulic brakes. Master cylinder. The master cylinder converts the force applied to the brake pedal into hydraulic pressure. Brake pedal. When the driver presses the brake pedal, it creates a mechanical force that is transferred to the master cylinder. Brake lines. These are used to transfer brake fluid under pressure from the master cylinder to the brake calipers or wheel cylinders. Brake calipers or wheel cylinders. Calipers apply force to the brake pads in disc brakes, while wheel cylinders apply force to the brake shoes in drum brakes. Brake pads or shoes. These friction materials press against the rotors or drums to create friction and stop the vehicle. Understanding ABS and electronic brake systems. In modern vehicles, anti-lock braking systems, ABS, and electronic brake systems are commonly used to improve safety and braking performance. Anti-lock braking systems, or ABS, is designed to prevent the wheels from locking up during heavy braking, which can cause the vehicle to skid and lose control. By preventing wheel lockup, ABS allows the driver to maintain steering control while braking. How ABS works. When the driver applies the brakes, the ABS system monitors the wheel speed using wheel speed sensors. If the system detects that a wheel is about to lock up, the ABS controller modulates the brake pressure at that wheel by rapidly applying and releasing the brake. This process, known as pulsing the brakes, prevents the wheel from locking while maintaining the braking force. Components of ABS. Wheel speed sensors. These sensors monitor the speed of each wheel and send data to the ABS controller. ABS controller. The controller processes input from the wheel speed sensors and determines when to apply or release brake pressure. Hydraulic valves. These valves are used to adjust the brake pressure during ABS activation. Pump. If necessary, the ABS system uses a pump to restore brake fluid pressure during an ABS event. Electronic brake systems. Electronic brake systems, such as electronic stability control and brake assist, use electronic sensors and controllers to improve braking performance, particularly in emergency situations. How electronic brake systems work. Electronic stability control helps prevent skidding and loss of control by automatically applying the brakes to individual wheels to keep the vehicle on its intended path. Brake assist detects emergency braking and increases braking force to reduce stopping distance. Brake-by-wire systems. Some modern vehicles use electronic sensors and actuators to replace traditional mechanical brake linkages, allowing for more precise control and faster response times. Components of electronic brake systems. Sensors. Sensors are used to monitor the vehicle's stability, wheel speed, and braking force. Electronic control unit. The ECU receives data from the sensors and uses it to control braking force and adjust individual wheel brakes. Actuators. These devices apply braking force to individual wheels in response to the system's commands. Brake-by-wire. This system uses electronic signals instead of hydraulic pressure to operate the brakes, providing faster response times and more precise control. Summary of brake system operation. Here's a table showing the summary of a brake system operation. You can pause the video if you want more time to review the table. Conclusion and recap. In this lesson, we covered the operation of hydraulic braking systems, ABS, and electronic brake systems. We discussed the components that make up these systems, how they function, and the benefits they provide in terms of vehicle safety and braking performance. Understanding these systems is essential for diagnosing and repairing brake-related issues and is a key component of the ASE certification test.